Welcome back to our videos on nth roots and rational exponents. In this particular video, we are going to be looking at some examples of how we might use these. As a refresher, we learned about the basic definition of an nth root and a rational exponent and how we work between them. And then we looked at a slightly more advanced definition that includes different types of exponents. And we have to remember when we're working with these that all of the exponential properties apply. So I'm going to keep these things over here on the right so we can keep them in mind as we work through our problems. So here we go, a couple examples. All right. For our first example, the seventh root of c to the fourth, we could rewrite this as c to the 4 over 7. The index here becomes the denominator of our fraction. The exponent inside is going to become the exponent. So this is c to the 4 over 7. Similarly, I could go from a rational exponent into a radical. I have my rational exponent. I can write it in either of these two ways. So b to the 3/4 could either become the 4th root of b cubed, or it could become the 4th root of b, the quantity cubed. Both of these are equivalent and acceptable answers. In general, unless a question asks you to change the format, you want to end the question in the same form you started. So here I have the 8th root of d raised to the 6th power. This isn't in a simplified form because 8 and 6 have a common factor of 2, and that's going to be an issue. I can simplify this out and write it in a little bit easier to read form. The way I'm going to go about doing this is I'm first going to use my definition to go from a radical to a rational exponent. So that means that this is going to become d to the 6 over 8. Well, the fraction 6 over 8 is not in simplified form. So I can simplify 6 over 8 as d to the 3 over 4. 3/4 is a fraction in simplified form, so then I can go back and I can write this as the 4th root of d cubed, or I could write this as the 4th root of d cubed. In general, I tend to like to represent things as the 4th root of d cubed. To me, that's a little bit more straightforward, but both answers would be acceptable. When I look at this next problem, I have the issue of having two indices that are not the same. I have the square root of f times the cube root of f squared. So I can't just combine these because the index is not the same. So what I'm going to do is I'm going to, again, in the same way that we went from a radical to a rational exponent in this problem, I'm going to go convert each of these from a radical into a rational exponent. So the square root of f in a rational exponent is f to the 1/2 times the cube root of f squared is going to become, the cube goes in the denominator, the squared goes in the numerator, f to the 2/3. Now I have the same base raised to different exponents, so I can add those, giving me f to the 1/2 plus 2/3. Now I have to go back and remember how to add fractions. I need to get a common denominator of 6, so I'll multiply the first one by 3 over 3, convenient value of 1. The second by 2 over 2, convenient value of 1. So I have 3/6 plus 4/6, which is 7 over 6. So this gives me f to the 7 over 6. So when I turn this into a radical, I have the 6th root of f to the 7th. 7 is a bigger number than 6, so I actually need to take care of this. This isn't quite finished. So when I finish this, which I'm going to do up here, I want to look at this. One way is I can take this 7/6, and 7/6 could be written as 1 plus 1/6. So I could rewrite this as f times f to the 1/6. Or I could look at this, and I could say that this is 7/6. This is the 6th root of f to the 6 times f. In the same way that f squared would come out of a square root, f to the 6 would come out of a 6th root. So this this piece here would come out, this would stay in. If I'm looking at this one, f clearly doesn't go under a radical, but f to the 1/6 does, and this gives me f times the 6th root of f. So this here is how I would simplify this. In general, we want just one radical. When I look at this question down here, I have a number raised to the 1/5. One thing that we're going to notice is that when we have an odd degree, we can have odd degree roots that are negative, or we can take the 5th root of a negative number. But I've got a couple things going on here, and the first thing I have going on here is this negative exponent. And what I remember, negative exponents, move it to the denominator. So my first step is to move this to the denominator. So I have negative 3,125 raised to the 1/5. So this is really asking the question, what raised to the 5th power is equal to negative 3,125? So I'm going to pull this out. This is my a to the n table. So this is 2 squared, or 2 to the 1st power, 2 squared, 2 cubed, 2 to the 4th. And I have that for 2 through 6 raised to the powers 1 through 6. And if I look on here, 5 to the 5th power is 3,125. If I want that to be negative, if I take negative 5 times negative 5, I get positive 25. Times negative 25, I get negative 125. Then positive 625, then negative 3,125. So this question mark should be negative 5. Negative 5 raised to the 5th power is negative 3,125. So that means that I can replace this denominator here. I could rewrite this as 1 over the 5th root of negative 3,125. And negative 3,125 is negative 5 to the 5. If these are the same, they can go away, which would give me 1 over negative 5, or negative 1/5. My other option is to go to this step here, and I end up, so I'm going to go down here, 1 over negative 5 to the 5th raised to the 1/5. And if I look at 5 raised to the 1/5 and my rule here, I'm going to multiply those, and I end up getting 1 divided by negative 5, or negative 1/5. I go through a similar thing for 256. If I pull my table back out, I don't actually have 256 here, but if I keep going with this, 256 is 2 to the 8th power. So 256 is 2 to the 8th power. If I take 2 to the 8th power and I raise it to 3/8, this is the same thing as 2 to the 8 times 3/8. Those 8's cancel because I have an 8 in the numerator, 8 in the denominator, and I get 2 cubed. 2 cubed is 8, so my answer here is 8.